Thank you very much for coming. We're now going to have a corporate partners working group session to learn about what we've been doing in our working group, and also to allow you to learn about some of the educational opportunities and interactions that we're going to have. And first, we'll have Allison North from Rockefeller give us an update of what we've been doing. And we thank all the corporate partners that have given input into this.
Thank you. Okay, so as Lisa had said, she and I are currently co-chairs of this group, this illustrious group, which consists of the following working group members. I'm not going to go through everyone in turn, but I did color code us to show that in the pinky purple, it's those of us who come from a sort of academic research background. In blue, it's those who come from the companies. And then in green, you'll see Claudia Fanda and Yara Rice from Eurobioimaging and Global Bioimaging, who are being external advisors for us to keep us honest and to make sure that we don't just reinvent the wheel and do everything they've been doing in Europe for the last 10 years. So we are looking to add new members. Jim Sims from Hamamatsu has already agreed to come on board. Just to address the diversity question, we did have a Mexican representative. Unfortunately, he never managed to attend a single one of the meetings because he's just so busy. So it wasn't his fault, but this is a challenge for everybody. So if anyone has suggestions, please let us know. Okay, so one of the things that we've been doing is working together with Nikki and Vanessa and all of these people who've contributed to this amazing core facility map, which enables it makes it very easy to locate specific technologies across the whole of North America. And so if you click on any of these points, it takes you immediately to a core facility who signed up and has indicated whether they are interested in hosting exchange of experience, collaborations, or demos. Importantly, this is now downloadable, which is very great, as a CSV file or PDF, and you can see there's a lot more people on it as well. It's very important. So I think a lot of the companies we find don't know about this. And it's very important for them to know if they're going to try and host a demo. We all know it's an awful lot of work to bring in a massive system and demo it somewhere. And so if there's one of their systems up and running somewhere close who's willing to host a demo instead and take people to it, that's obviously going to be beneficial to them. So please spread the word about that. It's also some of the groups, some of the corporate partners from smaller firms have indicated that it's very useful for them to do collaborative work with us. And we're actually discussing at the moment, should we be expanding this to imaging heavy labs as well as cores, or should it really just be core facility based? So please discuss that with us. And an important point is we're the ones who are responsible for keeping it updated. So if we get new systems and technologies, we have to add this. Nikki and Vanessa are not clairvoyant. They can't be expected to know this. Okay. So what have we been doing? See, I was going to make a joke about Abhishek, but I don't see him in the room. I was going to say, unlike Abhishek, we've been doing lots. So as you can see, one of the things that we've done in the last year and a half is we've had these talks from the corporate partners. So they indicated that for them, it would be very useful to speak to postdocs, graduate students, staff of core facilities to be able to recruit really good people to their companies. And from our point of view, there are all of these postdocs and graduate students who don't want a traditional career in academia. So this seemed like an obvious match. And so we've hosted now 15 of these talks. They've been absolutely amazing. Lisa and I have both learned so much from every single one, and actually found that we kind of want to do all of these jobs we never thought about. Like the very first one from Sam Tesfaye about sales, we were just like, hire me. So the average attendance is about 20. Yeah, we've had many attendees from all over. So the question is, has it been worthwhile? You may well be asking, because of course, every activity that BINA is undertaking, we really want to see impact. If we're all putting all of this work in and nothing's coming out of it, is it really worth it? The good news is, yes, I think it has been worthwhile. I think we would all agree. So we reached out to our presenters and we asked them, you know, how has this impacted you? Did you find it useful? And I'm with permission from Brian here. I am directly quoting from Brian Millis, that he said not only was it an honor and he really enjoyed doing it, but he got lots of requests for mentorship after it. And he really enjoyed meeting with them and discussing all of this. But, and this is the important point, the biggest success story for him, they've now hired or they are in the process of hiring one of the students who reached out after that talk for membership. And I know that at least one of our other presenters said to me that she had also had job applications which were a direct result from the talk she gave. So that's great. Okay, now another activity which unfortunately I was not involved in because I was in hospital. Lisa and Louise Bertrand from Leica hosted this incredible roundtable discussion at the ASCB meeting in December, joint between vendors and academic researchers. And I think they were kind of expecting maybe they would get one table of 10 people to discuss this over lunch, and they actually got about 4 to 5 tables with about 10 people at each. Huge amount of interest. And nicely, it was about 50-50 split between companies and academic researchers. And they just couldn't stop talking. So we had to have an additional meeting in February where most of the people came again to talk about which of the initiatives they've been discussing they would like to see pushed forward. So, for example, you're going to hear today about internships of researchers in companies. But one thing that we proposed was, well, would the companies be interested in short internships in cores so they could learn more about the business and how a core works, and so understand the challenges that are facing us. I think the better we can understand each other, the more we can work together. So shadowing opportunities, collaborations are very important, and of course, hosting demos. There's a big difference between hosting a very, very expensive demo, which does not really have an effect, and one that is a really positive experience. And that's why we were having a lunchtime discussion about that. We also hosted a presentation from the Eurobioimaging Industry Board to see whether our activities were aligning with those in Europe. And it was interesting seeing the differences. So the presentation in March was by Claudia Fander, who is the Eurobioimaging Industry Board liaison, and Herbert Schaden from Zeiss, who was at that time the chair of the board. There are a lot of differences, actually. Their board was formed about 10 years ago. It's now got 17 members and so on, but it's all members from industry, whereas we are mainly from academia. Sorry, we are both from academia and from industry, equal numbers. But all of these things, which I don't have time to go into, was interesting to see how they've been important in creating a kind of mutual respect between the companies and the academics that deal with them, and leading to webinar series on technology exchange and just information about grant opportunities and training activities and so on. So there's a lot of information there. So what are the next activities? What's coming up? So over the last year, we've had monthly meetings where we have numerous and long discussions, which are very interesting, to find mutually beneficial activities and approaches for the companies and the researchers. And we've talked about all kinds of things: sponsorship, education, researchers, how we can help each other. Should this Congress include workshops similar to the ELMI ones, for example, for the companies? Should we be hosting small local in-person meetings? That's what the company said they found were very helpful for them, rather than just the big ones. I know I'm running over time, don't worry, they'll forgive me. And there is a conflict. We have discussed at length this conflict that the companies, their job is to sell new equipment. And of course, all of us are wanting to keep old equipment up and running and donate it to areas that can't afford it. So this is a conflict, and we want to find a good way of addressing it. And also, would the companies be interested in helping sponsor people to attend courses and meetings, as I was talking about before? So one thing that really emerged as a primary wish of the companies was that they would like researchers to understand how deeply involved they are in microscopy education in all kinds of ways. And there's just little things that we've discussed that we can do which make them feel valued in that way. So, for example, I had an email after the OMIBS course from one of the vendors saying that just the fact that we stopped calling them vendors, we started them calling them vendor faculty, made a huge difference to them when they go back to their companies and they explain why they have to go to this course, because it's to educate, because they are faculty. Introducing technological presentations in any meeting, even if it's a 5-minute tech bite, they can say a lot in 5 minutes. But also longer demos they want to do, and longer seminars. Involving them in career panels has been very beneficial. And just the way we think of them, that we're thinking of them as a partner and a collaborator, and not just this salesperson down the road who's trying to sell us a microscope, because really we want their knowledge. So because of this, we decided that we're going to switch our webinar series for the upcoming year over from the careers talks to a new one, which is going to be about tools, educational tools. These can be physical tools, these can be internships, these can be, well, all kinds of things. You're going to hear about them today, because what we're doing for the rest of today's session, we asked several of our corporate partners, particularly ones on our working group, to just give us a talk, a little teaser about what they do, and then they will be following these up with a full 1-hour seminar online. So at that point, I shall hand over back to Lisa, who's going to introduce them. Thank you.
Thank you. So the first person we'll have in person, but we're going back and forth. So thank you very much for Lane Manning, who's a field engineer and optical filters and light sources at AVR Optics. So he'll tell us about successful fluorescence imaging by design with Semrock's Searchlight.
Thank you. Thank you. Hello, everyone. It is so nice to be here with all my BINA friends. Thank you. Thank you for inviting me. And Nikki and Vanessa, thank you again for all the organization. It's so awesome. My name is Lane Manning. I am a field engineer, but also team leader for optical filters and light sources. And we work with Semrock optical filters. We do some other stuff as well. You probably heard Peter talk about it on Monday, but I'm here to specifically talk about Searchlight tool from Semrock. So this is it right here. There is literally a little web address right here. You can go to that, or you can type in your search engine of choice, Semrock Searchlight, and it'll go right to that. And so what it is a spectral and modeling analysis tool. And it's free to use. You don't even need to make an account. If you want to save your plots and send them to people, you need to make an account, but otherwise you can just go on and plot lots of good stuff out. So you know, really what you have here on the left is just a menu of lots of different stuff you can load in there. So lots of different fluorophore and dye options. If there's ever anything that you think should be in there that's not, let us know. We have the quickest access to be able to add this. So if there is something that's missing, I know, you know, a lot of new fluors come out, and you know, it's very rapid development. So if there's something that's missing, just let us know. We can get that added. So, you know, a whole long list of those. And then you'll have the actual filters offered by Semrock and filter sets, as well as light sources, detectors, and you can actually add your own custom ASCII data as well. Again, if there's light sources or detectors you think we should have that aren't in there, do let us know. We can get those added fairly easily. And so really, this is just a modeling and analysis tool to help, you know, select filter sets to match your light sources, your fluorophores, and your detectors. All right, so as a quick little example, this is, some of you probably know this very well, but some of you might not know anything at all. So I'm going to go through sort of very basically and then a little bit more advanced. So you can select your fluorophore of choice. You can choose a little GFP, and it's going to plot your lovely little absorption and emission spectrum here. Once you have that, there's a couple of different options. So you can hop right to filter sets. So there are some filter sets that are designed specifically for certain fluors. In this case, GFP is quite popular, so there's a few different options. So, you know, there's sort of more broadband ones and more narrow band ones, but a few different options. You can just plot them, you know, double click on that and they'll just show up right here. If you don't want to do that and you want to get a little bit more clever, you can design your own sets. And so, you know, we actually do a lot of this because there are often not specific sets designed for some of the new fluorophores. So maybe you have to select your excitation, emission, and dichroics on your own. So that sort of menu is under here under individual filters, and there's hundreds of filters in there. And this is really what we do all day, which is select filters for people to use with what they're working with. So as an example, here is a Semrock filter, which is designated by a central wavelength, the first number, / the bandwidth of that bandpass. And so you can go through and select a dichroic and an emission filter individually. You can plot them all together here, which is lovely, and get your nice little filter set here. And as you'll notice on the left, there's a few different options here. So you can plot this in transmission, but it's also important to look at the OD as well, which will sort of show you the blocking that these filters are offering, which is quite important, especially on the emission side. You want to make sure you're not getting any excitation light into your detection channel. Perfect. So just very briefly, you know, on the excitation side, your light source matters. So, you know, the width of the filter and the blocking of the filter is going to kind of be chosen by what light source you're using. So it's important to know that, you know, these are some questions we might be asking you. You know, are there other sort of UV or IR emissions you need to consider that you have to block. Is it going to let through sufficient light, et cetera? So, I think most of you folks probably know how to choose these things, but just in case, it's always good to double check because sometimes we have folks that don't really know. And so these are a lot of questions that we answer. And then on the emission side, of course, we always really emphasize you have to make sure that your emission filter is getting good enough blocking of your excitation source, just because it is significantly brighter than anything you're going to be looking at from your sample. So you just want to make sure you have good blocking on your emission filter to make sure you're blocking the excitation light. Perfect. Very quickly, there's kind of a larger conversation about a trade-off between brightness and contrast. This is a lovely little plot that I like that really shows you, you can get a really wide emission filter to capture a whole bunch of light from your sample. But at some point, you kind of lose your signal to noise and you kind of lose your contrast. So there is sort of an optimal, bandwidth that we recommend, but honestly, it is sample dependent. So that's a little bit case-to-case basis, but these are just kind of some rules that we go by. So, if you ever have any questions, do let us know, but you can really kind of see the differences when you're plotting these different bandwidths. So just sort of a little thing to keep in mind. All right, perfect. So yeah, once again, you can go with a band pass on your emission side. You could also use a long pass filter and capture all the light you possibly can. But then, of course, your signal to noise is going to take a hit because you're going to be getting a whole bunch of other stuff in your detection channel as well. So, again, I think it's sort of sample dependent, but this plotting tool just allows you to kind of look at all that and do some analysis. So a real quick point on the OD plots. So everything I've shown you so far has been plotted in transmission. You can actually look at the OD blocking of the filters. And so one thing that we really, really emphasize for filter sets is there needs to be sort of a separation between the blocking of the excitation and the emission filter, just because if this crossover is happening a bit higher, what you're going to end up is that the OD is actually quite lower than you think for a lot of your excitation light. So we always recommend make sure you have good separation if you're looking at this in OD. So that's something we always kind of check for folks, because sometimes people really want to squeeze their excitation and emission filters together quite close. And what happens is if you do a crossover, then you are going to get a lot more noise in your detection channel. So this is just another way to look at it. So don't just look in transmission, check the OD as well. Perfect. There's also multi-band filter sets. So back to this kind of menu. Semrock is rolling out some really cool, quad band and pentaband sets to do multicolor imaging, which is really nice. So just as a quick example, here's some very popular DAPI, FITSI, TRITSI, Sci5. And as you can see, there's some pretty cool ways to look at all of these at once if you want to do that. So those are also all listed on those menus, just to kind of show you. I think they're really getting quite clever with how many bands you can fit into just standard filter sets. So I think that's something we always love to talk about because I think a lot of people are interested in doing something like that. All right, beautiful. One more thing I just wanted to talk about was crosstalk analysis. So this comes up all the time. And so if you have a sample tagged with a couple different things, so in this case, I'm talking about CFP and YFP. And so what ends up happening is you might get either, so we don't talk about bleed through anymore. I like the excitation crosstalk and emission crosstalk. I feel like this is language that we've kind of settled on that I really like. And so what you would say is for excitation crosstalk, you might get direct excitation of not just what you want to look at, but also the other thing that's in your sample as well. And so in this specific case, if you're talking about CFP, you'll notice that YFP absorption has this really long tail that sits right under CFP. So if you're exciting right here, what's going to end up happening is you're going to see both CFP emission and YFP emission. And then the emission crosstalk would be the emission of one fluorophore is now getting into the other detection channel. And so there is a way to analyze this in Searchlight that I just want to let you guys know about. So there's this little thing down on the bottom called the Compare System Calculator. So it's a little drop-down menu. And so what you can do is you load up either a filter set or individual filters, your fluorophore, maybe a light source and a detector. And one thing you can do is actually analyze different filter sets, sort of compare filter signal to noise for different filter sets for the same fluorophore. But what you can also do is then do a sort of crosstalk analysis where you take the same filter set, maybe the one that you want to use for YFP or CFP, but then analyze, well, how much of the CFP is going to get into the YFP channel. And so in this particular case, with the filter set that I just showed, If you normalize, which is really important. So a lot of these numbers are kind of relative, right? Because like when you're talking about light sources and detectors, it is sort of good to normalize to one or the other, just so you can get a good sense of it. But in this particular case, this filter set, for instance, this excitation filter, is going to let through about 6.75% of the CFP signal in your YFP channel. So there is a way that you can do a crosstalk analysis with one filter set if you're looking at a sample with multiple things in it and just say, well, what is my crosstalk going to be? And then maybe you can kind of either take that into account by choosing a different set, or on the kind of post, analysis side, you can adjust for that if you know exactly how much of one you're going to get in the other channel. So this is really helpful as well. So we're happy to talk with anybody about kind of using this. We've done this for, 10 color systems and 15 color systems as well, where you can't avoid the crosstalk, but you can deal with it if you know what it's going to be. Beautiful. So yeah, this is my last little example here. So here's the CFP and YFP, kind of like what we were talking about before. And yeah, so really what the easiest way maybe is to just choose proper filters to avoid that. And so what you want to do is maybe choose an excitation filter for CFP that is far away from that YFP absorption as possible. So really trying to reduce any YFP absorption there. And then the same thing over here, which is basically reduce the CFP absorption in the YFP excitation band. So just choosing your filters properly to begin with can really help with this, but then you can also analyze and adjust based on that. And then the very last thing I just want to say quickly, there's also a way to model these filters. So on this little menu on the right-hand side, there's this little 3 lines. You pick that, you go to model this filter. And what you can do here is you can actually model angle of incidence or cone half angle or polarization and see how the filter is going to respond to a specific polarization or angle of incidence. And so these filters will naturally angle tune. So with higher angles of incidence, they're going to blue shift. So if you're in a setup that's more open table and you have the ability, you can actually angle tune filters and dichroics to do very specific things. And that can all be modeled in this software as well. So I just wanted to point that out because a lot of people don't know about that, but it's a really handy tool. So again, if there's any questions you guys have, let us know. And yeah, so here's an example of just plotting out a particular AOI. Instead of 45 degrees, you're at 55 degrees with a cone half angle and a P polarization. And this is what the response is going to look like for the filter. So really handy. I think it's very helpful for folks that are building, that are doing things where maybe you have a standard product, but you want it to do something a little bit different than what it's made to do. You can model what that's going to look like. That's it for me. So if you guys have any questions, come see us or email me or reach out, and thank you again.
Thank you. At interest time, we'll move ahead with each speaker and we'll talk more at the end. So our next speaker is George Glekas. He's going to talk about a novel tool to monitor microscope performance, and he works with Evidence Scientific and is the National Application Specialist.
All right, thank you all. I appreciate the invitation, Lisa and Allison and BINA, to be here. Today I'll be talking about, as Lisa mentioned, I'm a National Application Specialist for Evidence Scientific. The art is formerly known as Olympus. And I want to talk today about a new tool that we've developed where we can actually monitor the performance of our microscope. Let me figure out the buttons. So as you know, one of the big needs for the imaging community in general, as most people in this room have been part of, right, is can we really track performance and quality assessment and reproducibility? Reproducibility is something that's always been very difficult in the field of fluorescence imaging. It started, there's an ISO, for confocals that came out in 2019. Quareb formed, I was just talking about that at lunch today, a little bit after that. And even over the last couple of years, again, from this room here, you've seen some publications where we talk about best practices for reproducibility. And also maybe how are you going to actually quantify the data and things that you need. So we're a microscope manufacturer. So from our end, how can we really help the community fill these voids that we've had as far as imaging goes? So if we look at a microscope, how are we actually going to monitor the performance of the microscope? And there's kind of like 3 parts of the microscope that we focused on. First is excitation. We're doing fluorescence microscopy. Can we track the laser power over time, both for short time and long times? So that's number 1, is the excitation side of things. Number 2 is the emission side of things, right? The detectors. are they sensing the same amount of light that they were 3 months ago or 5 years ago or 10 years ago? As Allison mentioned, people like to keep these things for a very long time because they are expensive, and that's understandable. So how do we track that, and how can we really see how the detector is performing over time? And then third is imaging performance. So pretty much all the optics between the excitation and the emission, how can we actually track those and see if something has changed over time? Has a filter started to go bad? Has a spectral grading started to maybe not perform as it should? So those are sort of the three things that I'll talk about and how we can monitor each of those three parts of the microscope and of excitation. We'll start with excitation. We do have now in our new system, the FE4000 point scanning system, a laser power monitor where we can actually track laser power over time. It's very simple. You can see we can go up to 10 discrete wavelengths on the system from 405 to 785. And all you do is click the little, I know there's a pointer here somewhere. Which one is point? Oh, this one. Thank you. That was it. Okay. So all you do is check the power of the laser here, and it'll give you a readout here. And you can see you can track it over time. We can also implement this for time series and that sort of imaging as well. But for the sake of this, it's a way to track laser power. And this gives you an idea. This is where the lasers that we use on this system, just a few examples, the 405, 48, 561, and 640. And you can see over the course of 6 or 7 months that laser excitation power can actually vary, not significantly, but to a certain extent, right? And so that we need to be able to control for that if we really want to track the performance of the microscope. Now, the second part of the equation is emission. And as you all know, older PMT-based detectors do degrade over time, especially with a gas coating, as do hybrid gas detectors. And so that was more problematic for us to really figure out a way, how can we still track performance of the detector over time? So what we did is we introduced a new type of detector. It is based on a silicon photomultiplier, and we have a patented signal processing technology on the back end to really unleash the full potential of that silicon photomultiplier. And we call it a silver detector because it's a silicon detector from the visible to the near IR. And if you want to talk more about that, I will definitely be at the table later. So how are we going to get the laser from the fiber all the way back to the detector? So the first thing we did is actually it's a piece of hardware where you can see it's a cube where the laser comes in and then bounces right back out. And it uses very little amount of laser, and it's a way to send the laser through the whole entire optical system. And it works something like this. So we start at the laser here. You go through a dichroic mirror, through the scanning mirrors, and then it gets bounced through the mirror cube. And now it'll go up to the detectors. First, it'll go through the pinhole. This is just an example from our confocal system. The VPH is our spectral grading that we have in front of the detector, and then it goes to the detector. So we can actually bounce the light through the whole entire optical system. And this will give us an idea, is the detector performing or is it something else? Especially in this case, the pinhole, is that somehow misaligned? And if that's the case, then we can detect for that. And we have software that'll tell you this is what's wrong with the system. And this is just a quick example. As we vary the pinhole, you can see it should have a nice peak at the middle of one area disk unit. And as we move it around, you can see that there are significant differences in the emission strength of whatever fluorophore we're looking at. Okay, so those are the first two parts of the equation. The last part is imaging performance. And this was a little harder. Traditionally we've used maybe fluorescent beads, which are really hard to get into focus and can have a lot of variability. So we actually designed another piece of hardware, and this is what we call our 3D LSF slide. It's basically a star pattern that can reflect back some of the light here. And it's very thin at the edge. And so it gives us a way to get a point spread function with a very flat surface. And it goes something like this. Now, this is the first time I've talked about this, so forgive me if it's not the smoothest. But basically what we do is we image around this star pattern. Oh, I pressed the wrong button. Let me just go back to, sorry. The one I'm on is actually the one I want. I just want to go back to slideshow. All right, I'm going to stop using the laser pointer. So basically we take a 3D image of this star chart at different points of the chart in different Z's, right? So we do a Z stack through all of them. And we can get what we call LSF. Instead of a point spread function, it's a line spread function. And when we do that over these multiple points in Z, we can generate data like this that is similar to, here's a 3D PSF on the left. When we do that at different angles in 8 directions, the 2D LSF gives us similar data. So we can see if there's some kind of something wrong in the imaging pathway itself. And it's a unique technology, and it's a way to really test the rest of the microscope system and are things working or not. Now, how does it actually work in practice? We have software that we've designed that can use these pieces of hardware. So it's really simple. You press start and you just hit next a few times. It tells you what you need to do, which lasers need to be turned on. Then it'll check the power, the laser power, and also the performance of the detectors. Then it tells you to put the slide on, get it into focus. That's what it looks like when it's in focus. And then it'll spit out at the end. It'll tell you, have you passed or have you failed? It'll look for laser power, it'll look for detector and pinhole performance, and it'll also look for imaging performance. So it's very straightforward, very easy, takes maybe around 10 minutes. So, if you're at a core and you really want to track the performance of the microscope, it's a way to do that very easily. So again, these 3 points: laser power, detection sensitivity, and pinhole performance, and then imaging performance. So that's what I have today. We do have a white paper out on it. I'm not sure if that QR code will work because it looks fuzzy, but but you can always go to our website and have a look there. So with that, thank you all for your time. I appreciate it.
Oh. Thank you, George. Oh. Which one? On now. That's not on. Wait. No, wait for me to talk.
Yeah. Go ahead.
Okay. Our next speaker will be Nicolas Vandervoort from the Scientific Volume Imaging. His title is Director of Scientific Affairs, and his title of his talk will be Huygens Quality Control, Identifying Correct Image Pitfalls to Discover the Truth Behind Your Images. Thank you.
Thank you very much for that introduction. And by means of further introduction, I'd like to start a bit by telling about the history of scientific volume imaging. We actually started out in 1996. And this is pretty early for a company that specializes in software, because at the time there was no startup funding or anything like that. So we essentially bootstrapped ourselves using our early customers. And so from that point onward, we've been making deconvolution software, which we are best known for. So that's confocal and wide field. And then in the 2000s, as STAT was developed, we added also deconvolution for STAT. We added deconvolution for multiphoton. And then in the 2010s, we also included light sheet and array detector. Then in addition to that, from the 2010s, we also started making analysis tools. So that is colocalization analysis, object analysis, tracking. So by now we have a very complete software suite that you can essentially run all your experiments in. And this, we read in data types from any vendor. So you can do you can do analysis from any vendor in Huygens. Now, we started as an independent company, and we still are, and we actually have continuity in the leadership, so we will remain independent for the coming period, and we just have a very creative team behind me. So in the last 30 years, we've been receiving lots of images from lots of microscopy users, and we've been seeing all kinds of artifacts that occur in these images, and so we have a lot of know-how to address that. And what we did is we put all that know-how and all these algorithms that we have in the quality control tool that I'm going to speak about. So I was recently at a workshop, and I was giving a workshop, and I asked the participants, how many of you have experienced bleaching? And all the hands went up. Everybody knew bleaching. And then I asked, how many of you have experienced crosstalk? And then no hands went up. And that just, to me, is extremely suspicious, because it's more likely that they don't know how to recognize it. So being able to recognize a certain imaging artifact is the first step in correcting it. So And that is very relevant, you know. So the quality control tool first gives you a way to recognize the artifacts in your image, and all you need to do is essentially insert the image into Huygens, press run, and it will tell you. So if you're an imaging core and you have lots of users and you love them, but it costs you a lot of time just training all of them, then you can essentially spur your users to first run it through the Huygens quality control, save you a lot of time that way. So another topic is, of course, microscopic metadata inspection. And because we read in file types from many vendors, we can also say very well when certain metadata is missing. So, you know, it can be that you're using maybe a format that's less used and that we don't support as well. And then Huygens will also say, okay, I cannot read this. But then when you're using a format that's so rarely used, you might want to consider moving to a more common format. So that's either open source or commercial. A third topic is the point spread function. So there's been a lot of discussion going on how to accurately measure the point spread function. And you might want to do that either to check, check the performance of your microscope over time, or you might want to do that to, put in your reporting when you're writing an article like the state of my microscope was so-and-so at the time I took my data. So to measure PSF has a bunch of challenges because, you know, if you use beads, you can have bleaching, and if you have and you inherently have a noisy image that you get from your bead. So we have a rather elegant solution for that. So we deconvolve the PSF out of the bead image, and in that way we can generate a 3D model of the PSF that is unique to that point of your microscope. And of course we can derive certain characteristics from that. So for example, we can get the full width max, we can get the skewedness, the asymmetry. And so I got a comment this week saying like, how can you distinguish a banana PSF from a good PSF, because they might have the same full width max. But if you actually, if you combine these different parameters, you can actually distinguish them. So the QC tool, it has as a philosophy, like I said, that it takes the raw data and the raw data alone with the metadata. So no additional measurements. And on that, we draw as many conclusions as we can. So I don't have time to go through them in detail, but I just mentioned them. We check for undersampling, right? Microscopists need to learn that they need to use the proper sampling. Metadata is missing, it will report it, like I said. Chromatic aberration, we detect for on the raw data. Clipping, we also look for. Hot or cold pixels, if you have a camera. Bleaching, crosstalk, misaligned plane. So if your stage is a bit shaky, then we can detect that as well. And the PSF, as I mentioned. So this tool actually comes in two variants. There's the licensable option for the Huygens software, and we have a free online tool. So if you want to use the free online tool, all you have to do is you can make an account, you can upload your data. We accept up to 250 megabytes, and we read in many file types, and it will spit out a PDF. And the PDF, it includes both an analysis of the issues that it found, as well as explanation on what underlying theory is of that particular issue or artifact, as well as giving you hints how to optimize your acquisition procedure to prevent it. Now, if you have the licensed option, you can actually, you get a few more options. You get also, you can get these options in, you can get more detailed analyses. You can interact with the data, and you can also correct for many of the artifacts that can be found. So what you get then is, let's say, the image on the left. This is, well, of course, it's dominated by the hot pixels you see here, but it's also, there's some clipping going on, which is actually caused by the hot pixels. There's bleaching, and there is crosstalk. So if we fix all of that, and we do the deconvolution, we get a high quality image that we can then further process and analyze. So a small disclaimer, as I said, we only take the raw data as input. So if you see your signal drop from 1 week to the other, we can tell that the signal has dropped, but we don't know whether that is because your fluorophores have become more sparse or whether that is because your laser might have died and your excitation has dropped. So then you need to combine that with orthogonal measurements to supplement that information. Now, furthermore, we try to add a interpretation to the measurement of the aberration or artifact that we found. So it might be that you have a very mild aberration that's not really harmful for your analysis. And it might be that you have a more severe aberration that is harmful. And in the end, where you draw the distinction is arbitrary. We try to do that using our experience to guide the user to do that. But we might be wrong. So if you have a specific case where our calibration is not good, then also please let us know. Yeah, and you should visually inspect it, right? So if it's good as an automation tool for users, but you as a facility core manager, you can still use your experience to judge. This brings me to the end. I'm looking forward to the discussion. I really enjoyed all the opportunities that are being presented here at BINA. We are located in the Netherlands, so we'll be able to use only a few of them, but I'd wish we could utilize more. Thank you.
We're going to transition to a virtual talk. Well, thank Jens Kuchenmeister from Thor Labs. He's staying up late in Germany to give us this presentation. So the optical microscopy course educational kit is one of the tools that Thor Labs has, and he will also be giving a presentation later in this fall about that in a longer presentation as part of our working group. So if this little teaser, you want to learn more, please remember to check us out. So thanks.
Yes, so good afternoon, everyone. So I hope that you know Thor Labs as a manufacturer of both complete optical microscopy systems as well as optical photonics components. I personally lead a group that develops a line of educational kits, one of which is the optical microscopy course. And I think it's worthwhile to just spend 2 minutes on the kit line itself, because it explains why we're doing what we're doing and how we're doing it. So these are the kits that we have. There's a bit of quantum optics up here. There's an educational atomic force microscope, optical tweezers, Fourier optics, and a couple of more. And the reason why we developed those was we wanted to give back to the photonics community. So the idea is not really to make a lot of money with those. The idea is to excite the next generation of students to go into the field of optics and photonics, physicists, biologists, engineers, because, the more bright people are in our industry, the better off we are. And the way that we go about this is that we try to give as much help to the educators as possible. So first of all, we write up really extensive manuals, and they are free for download, because the idea is, even if you may not be able to purchase the kit, you can still look at the educational material and use it for your teaching. The second thing is that we price those kits at the sum of their components, meaning that all of the research and development that goes into them, which can be a couple of years actually, is not reflected in the kit price. And so the value for money for these is quite good. A few words on our design principles. Now, when you look over these kits here, you will immediately see that we really dislike black boxes. So we try to stay as open as possible. We want students to adjust everything themselves. It's our teaching philosophy that, only when you really have every element in your hand and you know its purpose and you can change things, you really understand what you're doing. This comes with a responsibility on our part, because we need to design those kits such that students can get reliable results, right? There's an alignment procedure in place that they can follow. Then we try to use visible light if at all possible, and we stay away from overly expensive components that are not needed to achieve the educational purpose. Now, without further ado, this is the kit that I want to talk to you today about. It's our optical microscopy course. You can see here, it consists of kind of a rail with all these different optical components. There's a little parking space here with even more stuff. Then there's a little bin with all kinds of little helpers that you need when you teach microscopy. There's samples, and there's even a spectrometer in here. And the goal of this, and I can't overemphasize that enough, is to understand the techniques of microscopy, right? If you just want to have a nice image, you can buy teaching microscopes for like $300 or something that will give quite good images. But that's not the point here. So what we want to convey is how are the individual techniques distinct from another? How do I go from one to the other? And the idea is really that the students can set these up from scratch. Now, it won't surprise you that this includes everything that you need. Everything fits together, right? So that's the whole point of a kit. And obviously the question is, how much does this cost? When you go to our webpage, the prices are always open, and you can see that this comes at just above 11K. It's actually, in this case, it's even a little bit cheaper than the individual components because we discounted the spectrometer quite a bit when calculating it into the kit. Now, this is something that we did not think up in our dark cellar somewhere at Thorlabs. This is the result of literally a decade-long collaboration with Neil Switz and Dan Fletcher from UC Berkeley. And it was incredibly fruitful. So they had a lot of input, and a lot of their ideas, understanding microscopy and what the needs are, made it just to standard catalog items for Thorlabs. And they also sort of thought up this microscopy course. And the awesome thing is, it's not only all of the know-how that goes in there in terms of hardware, they also contribute their documentation. And so this is what you get with the course. You get course notes. So you can really have a lecture. You can start a lecture from scratch, basically, by just taking their course notes. You have lab notes, and you have instructor notes. So really, you buy the kit, you can give a lecture, you have the lab notes for the students, you have the instructor notes for the teaching assistants. And this is accompanied with even additional material on the web page, for example, alignment videos here. So that's the real treasure. This is their real life experience. They made several iterations with the course and ended up with the content that they have here. And what do students actually learn from it? Or what do what could your employees, for example, at the core facilities the work they learn from it? Well, obviously you start out, how do I illuminate a sample properly, right? So you have deep looks into Köhler illumination, and you look at the individual optical elements. So what's the purpose of the individual lenses? What's the purpose of the irises? What happens when I change those, right? This is quite fundamental. Then the next thing would be backfocal plane analysis. So in the backfocal plane of the objective, you can find some funny stuff. You can even do a little bit of Fourier optics, and you can see here there's a beam splitter in the camera. So you can look at the backfocal plane with the camera. Next thing is obviously bright field microscopy with a lot of samples that are in the kit, and a couple of them you can make yourself. For example, what you see here is just a bit of lens cleaning tissue. Then there's also a proper target in there, USAF target, Ronchi ruling, and all of those different stuff that you need to characterize a microscope, right? Because you want to go up to like something like a point spread function, obviously. Then dark field microscopy and phase contrast is part of it. So as you can see here, we're switching from bright field to dark field. And the whole point of this is that you can switch there really easily. It's quite fast. In a couple of minutes, actually, you can go from one to the other. And finally, fluorescence is part of it. So again, you see here the lens cleaning tissue from before, and we marked it with the included text markers. And then you have the matching filters, and you can see nicely what fluorescence microscopy is all about. Then, of course, there's some pre-prepared samples. And in order to understand fluorescence, well, you have to look at the spectrum of your light source. You have to look at the filters. And so this is why the spectrometer is included in the kit. So to wrap this up, again, it's important to understand we're not looking for pretty pictures. We're looking for deep understanding of the microscopy methods. And this is why you have all those individual components that you can work together with. You can exchange them for different focal lengths, for example, and really examine what happens in the microscope, what happens to the image. It's a complete kit. All of the stuff you need here, all of those little helpers are coming with a kit. You have this vast documentation. I invite you just to browse through the webpage. So when you go to Thorlabs, you can type in this item number edu-omc1, and you can look at this in detail. As I said, you can download all of that here. There's just a slightly shortened version of the instructor notes online so that your students can't peek ahead. Yeah, I'm more than happy to discuss this in further detail. And as was already said, there's going to be a longer talk later this year. I'm happy to talk about it in a couple of minutes, or just send me an email. Thanks so much.
Thanks so much, Jens. Sorry for that. So we'll look at a different aspect of teaching and how corporate partners are very important in this. And we have Louise Bertrand, who is the product performance manager from Leica. You've probably all at least seen her involved in many courses that she supports. And she's going to give us some of the corporate side of things of how we can interact well to have commercial collaboration in microscopy education.
Thank you, Lisa. Thank you, BINA. Thank you, Alison, for having me. When Alison and Lisa mentioned to present tools that help the community, I decided to present more what is the commercial collaboration in microscopy education, because every year, before my time with the company, we have been supporting courses. And I will not be talking about Leica. I am talking about the 4 main microscopy company. I will mention some of the smaller company. I'm probably will forget people, so I ask you to excuse me in advance if I didn't put the name of the company on the PowerPoint. We have 3 main institutions where more than one course happens. So we have the Marine Biological Laboratory in Woods Hole. We have the MDIBL, that is the Mount Desert Island Biological Laboratory, that is in Maine, Bar Harbor in Maine. And we do have here in the bottom right, Cold Spring Harbor Laboratory, that is in New York. Every year, there is the main courses that everybody knows that are in bold. So if I go by order of the courses, I consider the Montreal Light Microscopy course a small course because it's 1 week. The same for the Analytical and Quantitative Light Microscopy that is in Woods Hole and OMIBS. And we have QIAA that is in Cold Spring Harbor. Yes, we have over 30 courses that we support through, I will say, March. Until now, I have a course at the MBL that it's called Frontier in Stem Cells and Regeneration that starts next week. So we still have equipment on the road until mid-October. What is involved? If I go by chronological order, QIAA, that is the quantitative imaging from acquisition to analysis, start usually in April. May, we have a QLM. In May, we also have QFM, that is the quantitative fluorescence microscopy. Now, in 2 months, we have 3 major courses. 2023 was extremely interesting because we had 1 week to move equipment from one course to another and make sure it's set up. It's ready to be used by all the participants and the people who are there to teach. I almost had a heart attack at QFM because the truck break between AQLM and QFM. It arrived on time. We work all night to set up the equipment for the next morning, but it arrived on time. I was talking with my colleague Jeff yesterday, and he was telling me that at QFM, One time he went there, the new building was not existing, and they set up the confocal in the basement of the building. And when they arrived there and unpacked the system, the basement had dirt floor. They had the system working for the course, and they needed to pack it after. So I needed to mention that. At the Marine Biological Laboratory, we start, my colleague and I, with FIR, that is before EQLM. And as I mentioned, we go all the way to mid-October. I will switch slide because not every company supports every institution. So the Marine Biological Laboratory is supported by the 4 main microscopy companies, Zeiss, Nikon, Evident, and ourselves. But if we go to Cold Spring Harbor Laboratory or the Mount Desert Island Biological Laboratory, only 2 companies, 2 microscopy companies support the courses. We align. The main courses always request the same equipment from all the vendors, so we try to teach all the same thing on all the same equipment. So we bring manual microscope because, as our colleague from Thorlab just showed you, you learn how to build a microscope. Our goal is to make you understand from the building of the microscope, how does it work on a manufactured microscope? What do you do? Where the component goes? It's a little bit different. The railing microscope is this way, and our microscope is, if it's an upright, is this way, and if it's an inverted, it's the opposite direction. So this is one of, I call it, tools we use to teach people and educate people. And I like the term that Alison mentioned earlier. As vendor faculty, we try to give you as much as we can. What is the equipment range? It can be, for example, if I take the 4 main courses after EQLM, that is neurobiology, embryology, physiology, and SNB, it can be a simple stereo microscope for screening, sorting. You need to look at the sample, all the way to super resolution. So each company have a confocal. Some company have a little bit higher super resolution. My colleague Chris, that will talk after me, they have an Eriscan. We brought a STED system. So we cover a full range of equipment for people that just want to look through a dissecting microscope, people that want to do imaging, long time lapse, all the way to confocal. What does it involve? Everybody arrive at the course, oh, look all the nice microscope we have. There is a lot of involvement. I didn't finish my year yet. The course is still going. I didn't do my summary of the year, and I already received requests for next year. So there is a lot of involvement. There is, first, we need to close the year. We need, at least LICA needs, I need to write educational grant every year for all the equipment that people request. I need to justify why out of the field I'm bringing the demo equipment, and I'm allowing you guys to use it during the courses. When this is approved, I can bring the equipment. If it's not approved, I'll make it approved. It's all, most of the time we don't have the equipment. For LICA, the end of the year is December. We try to sell all the demo equipment that we have. So I arrive in January or end of January, that's where I ask to have all the equipment requests. I go back to my higher management team and I said, this is what they want. I had a course this year that asked me to have a high-end imaging system for 2 students. There is 26 participants. That means 13 microscopes, 1 course. I said, no, I cannot provide 13 microscopes for 1 course. So getting the equipment, getting the specification required, working with all the logistics, having the equipment received, packing, shipping, setting up. We need to coordinate with field service engineer. We're not allowed to touch laser-based system. I need to have a team to help setting up. We don't have people that are located in each institution all year long. We don't have that manpower. So most of the time, I love the fact that we can do remote session and connect to the system when we are far away. Support of the courses. People don't think that when we go as commercial, I will call it vendor faculty, there is lodging, there is food, there is travel, there is airplane that we need to take some time. And then at the end of the year, we need to dismantle, pack, ship back, get an email back saying we are missing piece A, B, C, D. Do you know where it is? Okay, where was that system? Let's figure out. And some of the equipment comes back broken, so it needs to be repaired. Just as an example, this is when I set it up at MBL this year, the top picture. And this is just an example of few crates that we shipped out of MBL. This year at the Marine Biological Laboratory, we shipped out 24 pallets. So this is just to give you an idea that as vendor faculty, we love supporting the student, we love teaching, we love interacting with you guys, but I will say, don't ask at the last minute for a system. That will not happen. And be conscientious when you use the system. Don't leave it on. I arrived at 2 other courses this year to pack the system and everything was on. And then I said, okay, lifetime on that light source is about X thousand of hours. Since when is it on? So the new system, it's sold after that. There is warranty, but be kind with your colleague and be kind to the next person that will have the system after you. And this is just a little overview of the tools or toys that we provide to the summer course. My colleague from Zeiss, Evident, and Nikon, as well as ourselves, for all the community. Thank you.
And now we'll hear more about how maybe you can learn more about what companies are doing in their different parts of their company. And we have Chris Suand here from Zeiss, who's the North American Product Training and Pricing Manager. He comes from us from Canada, so we have some geographical diversity also. So he's going to tell us about some of the possible internships that he's been involved in helping out with people getting experience at Zeiss.
Thanks, Lisa. Thank you. I'm so pleased to be able to be here in person to present rather than be a virtual head. So I'm grateful to be here. I learned something about myself today. I learned that I've worked for Zeiss as long as Huygens has been in existence. So I have just over 30 years of experience with the Zeiss company and a couple of years with Leica prior to that. So hello, my name is Chris and I'm a microscopist. I've held a few different roles with Zeiss over the years, just to give you sort of a sense of my background and why I'm talking about this today. I started in sales and moved into product management, into product marketing over the course of 3 decades. And in the last couple of years, I've moved into a role that I think is the one that I value the most of all the years I've worked with the company, and that is being an educator and teaching. And one of the questions that I always find myself, or conversations I find myself getting into with my students is, how did you find your way to our little company? What led you down the path to becoming a salesperson or becoming an application specialist for the company? And I've yet to find a common theme. Everyone has their own path and their own story. But what I wanted to do today was to maybe provide some guidance to you or some insight into how people can find a role in a company and make a transition from the academic world into the commercial world. And either with one of the old 4, I think we got called a couple of days ago, but old wine is good wine, right? So this one, I just want a clicker to change the slide. Oh, this, okay, yeah, perfect. That's good. That's good, thanks, perfect. Yeah, so the value of an internship, that's really what we're talking about is internship. So Zeiss offers, and other companies as well. I tried to be a bit agnostic in this talk, right? But the experience I have is with Zeiss. So we'll talk about the Zeiss internship program. And the way I view it is an internship could be considered an extension of one's formal education. Or it's outside the context of the university, but it's still really you're learning something. And so I consider that as an educator part of one's formal education. I think an internship can bridge the gap between industry and academia and allow an intern a pretty unique opportunity to get insight to how a company is structured and what companies do. And at the same time, you know, we don't do this for selfless reasons. Companies need good candidates. It's hard to find qualified, motivated people that really have a sense of what it means to, yeah, you know, become part of a team. And so, yeah, it allows us access to a pool, right, of highly qualified and highly motivated candidates. And I put this picture here for two reasons, and one of them is obvious, right? This is Chandras Patel. He was a summer intern with Zeiss back in 2022, and he spent some time at the Zeiss Microscopy Center in Dublin, California. But the astute of you, if you look at this picture, what's wrong with it? Yeah, and the mirror is backwards, right? So Chandresh is still learning how to use a microscope in this case. But yeah, I only noticed this after I put the slide into the presentation. I'm like, oh no, I'm putting this in front of a group of microscopists. So I turned it into a test question rather than a mistake, right? So the idea of an internship or an apprenticeship can give a person insights into the different types of roles that exist within a company, and maybe hopefully help them sort of plan out or plot out a career path, right? What do you want to do with your PhD or with your master's degree or with whatever level of education you have? It allows them to access and see what different kinds of roles exist within a company, because I don't think they're all really readily obvious to somebody. Most people that work in a lab or run a core facility, they interact with salespeople, right? And maybe occasionally a service engineer if something breaks down. But there's an entire organization that sits behind those people to support them, and they need motivated, well-educated imaging scientists as well, right? So the internship, one of the internships, I should say, can give insight into roles in sales, of course. That's kind of the obvious one, but it roles in technical support, instrument service, application development. You know, we employ scientists to create workflows and work streams and applications, business development, marketing, product management, customer service, and leadership. And all of these roles, people tend to work for Zeiss for a long time, and their career sort of evolves as you spend time with the company. So, you know, people at the top of our company, the leaders of our company, started off as interns, as apprentices, as sales proteges, as we used to call them. So that's the value of the insight. So here's one of our, there's Shrandes Awel, or Patel, again, sort of sitting with Amita. She's one of our application scientists in Dublin. He spent 2 weeks during his internship there learning how to run advanced systems and how to sort of demonstrate microscopes, right? I put this one up here because I like this picture, and we talk a lot about the MBL because it's such an important part of what we do in terms of being educators. This is Celine Diaz, and he was the summer intern at the MBL this year, right? So he helped the Zeiss effort in terms of, putting microscopes together like Louise has to do all summer long at the MBL. And so that's a different type of internship. So internships can take different forms, and we'll talk a little bit more about what those can be. And these evolve, these types of internships and how they're structured evolves over time. So that's not a static thing, but if we think about what happens at the MBL, so we hire one and hopefully sometimes two interns to spend 10 weeks at the MBL working for Zeiss. They become an employee, they're paid, they're given a Zeiss email address and a laptop and a phone, and they're there to support our embedded product manager there. And they learn, they extend their education, right? So Cillian is a student at RIT, right, in the biomedical imaging course there. And he's able to extend his knowledge by being an intern. And for him, at the end of this, I had a long chat with him on the last day, and it's like he realized, he thought maybe he wanted to be a salesperson, because that's kind of the obvious role when you think about a big company like Zeiss. But he said, Chris, he goes, I'm interested in fixing things. I'm not interested in selling things. So in his mind, a service engineer, a service role is really what he sort of found out about himself after that 10-week internship. So I think being able to give somebody insights into what they want to do that quickly and that profoundly is powerful and really rewarding for me. So there's Cillian, after working as an intern for 10 weeks, running a FRED experiment on the LSM at the MBL. So good for Cillian. We wish him well. The next one, we talked about service. So the service apprenticeships, this is a little different, right? You might be surprised to know that Zeiss currently employs 6 service apprentices across the country. We have more service engineers than salespeople. It's about a 2-to-1 ratio because we need to support our microscopes. So service interns will join the company typically for a time span of 6 to 12 months, where they shadow a service engineer and they learn how to repair things. They learn how to troubleshoot microscopes and how to do preventative maintenance calls and things like that. And after doing that for 6 months, if an opportunity is available within the company for them to be hired, then this is a perfect candidate for us. So they get to learn if that's a good role for them, and we get to have somebody that's ready to hire if a position is available. So they're really a win-win type of a situation for us and for the intern. The other internship that's probably the one that's closest to my heart is the summer internship. And I think Quinn, if you're in the audience, Quinn Lee's over there, Quinn went through this in 2023 for Zeiss. So if you want to talk about internships at Zeiss, she's probably more knowledgeable than I am on this because she lived through it. So this is a 7 to 8 week summer internship for imaging scientists, people that are finishing their degree or perhaps finish their PhD or at some point near the end of their academic career where they're trying to decide what it is they want to do. They don't want to become a PI. Maybe they don't want to stay in research. They want to move out into the commercial field. And this is a type of position or type of opportunity where a summer intern is able to work in a lot of different departments within the company. So within sales, they spend time with service engineers, with the marketing team, with the executive management team for a brief while to understand what kind of positions exist within the company. So it gives them an insight into different roles that are possible. So you can see these are the 3 summer interns we had back in 2022. And the reason I chose 2022 wasn't because it was special. Those are the pictures that I had. So those are the reasons we put. And they get to take apart fancy microscopes and spend time really sort of learning the nuts and bolts of how things work, because this is a day in the life of an account manager. It kind of looks like this. It's a wall of text. We don't have to read the whole thing, but I just wanted to point out the fact that, internships aren't just done in an ad hoc way. They need to be structured. They need to really have learning objectives in place. I'm a big fan of establishing proper learning objectives as an educator. I really enjoyed the education and teaching working group session from this morning. That really resonated with me. But it kind of goes like this. You spend a week onboarding. You maybe, that's where you sort of get Zeisified a little bit. And then you shadow people, or you shadow an account manager for a couple of weeks. You shadow service for a couple of weeks. Spend a week in the Zeiss facility in Dublin. So we fly them out there. And they'll spend 2 weeks working in the application lab with our application scientists running systems and developing their knowledge as a microscopist, as an imaging scientist, but also finding out what it's like to actually work on the industrial side of things. And then they spend a little bit of time with the product marketing, and you get the idea, right? So there's a structure to this. And at the end of it, after 7 or 8 weeks, they make a presentation, right? There's no free lunch. You need to actually show and to show to the executive management team what it was you did and what it was you learned. And that sort of is like their little capstone project. And at the end of the day, you go back to school, right? Finish your degree or do something else. I just wanted to point out a successful case here. This is Linné. You can read it. Yeah, so Linné was an intern back in 2022, and now she's transitioned to be an account manager within Zeiss. So she found her career path, she found a job, she lives in Connecticut, and she's a very successful salesperson for Zeiss now. So that story can be repeated many times, but I show you one because that's what I have time for, and it kind of makes the point. And yeah, and that's it from my side. I hope I gave you some food for thought. If you are at the stage of your life where you're trying to decide what it is to do, come and talk to us. Talk to other companies as well, because they have internship programs as well. It's not just Zeiss. If you're not at that stage in your life, but you know somebody that is, maybe you can help point them in the right direction too. And thanks for your time. Appreciate it.
We welcome questions about each of those presentations, or general questions that you'd like to have about what. But we have less time maybe than you think, so we have about 10 minutes. Who would like, please let us know. Questions? Chris, how many people out of the internships in 1 year usually end up being employed at Zeiss?
One. Which is, I mean, it doesn't seem like a lot of people, but, you know, we're not a massive company like you might think, right? There's not that many people. We don't hire new account managers all that often, so one is typical though, yeah?
Oh, sorry, we hired two because I don't hire.
So I have a question. Would you be, so not only Chris, but all the other companies, would you be open to internship, but for core facility staff, because they have already, let's say, basic knowledge, and so they will be easy to train, and they can be also a very good partner for you when you, you know, when you have some solution or when you need some diagnosis that will help even your service, or will help even, I would say, research leaders to find the right equipment or to advise them. So be your partners. You know, the objective will be for you, the win will be that we'll be trained enough, we'll have enough knowledge about from technical to also the management part in the company to be your partner to speak with the researchers that sometimes they come to us and what do you think I should buy or and also for, very basic maintenance on our equipment. And as I said, yeah, diagnosis. So your service can also help us to repair faster.
You asked a lot of questions there. I'm not sure which one to answer first, but I want to clarify something. Are you asking that would it be a good idea for an intern, a Zeiss intern, to spend time in a core facility? The other way around, for a core manager to come as an intern working for Zeiss? I had never really considered that. I mean, so the answer to the question is yes. But my favorite German word is Jein, which kind of means maybe, because I don't know if that's something that I'd be able to do. I think it's worth discussing more. We need to sort of find out what the common goals are. And I imagine your goal is you want to be able to run your core facility more efficiently, right? And more effectively. Right.
So it doesn't need to, oh, sorry, thank you. So it doesn't need to come just to diagnose and see and then order the part and after it,
Right.
we save maybe a week or two. No?
Yeah, we talk about that as well at a different time, but we did do a service training session, I think. I forget what it was called, Allison, but
I heard about it.
Yeah.
Are you ready to do it again? And also those are companies. I mean,
yeah, maybe Allison wants to comment on that one.
Yeah, we did run this pilot. There was a lot of interest, particularly from people who work in remote areas, that could they get a basic service training from Zeiss? And so we ran the pilot with Zeiss in Thornwood. They were great. We got George Kopchik, who's the best trainer in the universe. And there were 4 people. I think Michelle was one of them. And I think it was great training. They taught them all kinds of things like how to switch in a new laser and so on. I will say, I think there was a slight problem maybe with the design of who was initially picked, in that certainly Christina from my lab went and Michelle went, and these are people who already have good service support. So Christina comes back all ready to do it, but our Zeiss service engineer is so amazing he didn't want it to touch the microscope. So I think of this is something that we could revisit if there's enough interest, but I think it is important that people are picked who are coming from areas that really, really need it and can't get access to good support. Correct. It was confocals, yes.
what about just general white fields that we usually don't have, we don't pay for the maintenance contract, but we still have issues. You know, like we saw since the beginning also of the week that we have dinosaurs. And sometimes for example, I need to change a stage. But I'm also afraid of what kind of screw I need to remove or not.
Just to clarify, I'm still running my Axia plan from 2000 that Chris demoed to me. So, so yes, we do. And that's actually a very good idea. And let's discuss that in the working group.
Yeah, I don't think we can give the final answer, but I think it's something worth discussing further.
Originally I was going to comment on the service engineering one, but I would say that we've also asked our service engineers to train new staff. The problem is they can't really get credit for that. And so we've come up with different ways to put in different service tickets or actually get a demo listed or something like that so that the workshop faculty more of a role that was recognized by the companies as teaching hours, that could be something that either engineers or application specialists could get credit to do, especially in remote areas.
Service engineers do have to account for their time by billable hours. So if they're doing something for somebody, they need to be paid for it.
that's kind of the reality of how the business works, yeah. I speak for the old four.
So I know that ZEISS in Germany is offering actually these courses, because currently just one of my staff is attending 1 week course about confocal microscopy. So that, but it's expensive, or I think it has the correct price. It's around 3,500 euro, but that's the way, because it's just 6 people and it's well supported. Also, again, to that point, it's clear we forget that usually a service engineer costs around 300 euros or even more per hour. So you have to think about if this is a way how you to get some information. I think that should be better prepared, so that you have more than just 1 or 2 people listening to a 300 euro hour. Yeah. Okay. I have another question.
Just to comment to that, yes, it was expensive, and that was actually one of the reasons that the people who went to the course were generally from well-funded course. However, perhaps this is something that BINA exchange of experience funding could be used for.
We'll get it replaced at the end of the session. Thanks, Roland.
So the evident tool, would you be able to get maybe 2 or 3 of these so that we could evaluate that within Quareb, and also that you open the analysis which is behind that? Because we are all the time looking for alternatives to beads, yeah? It would be maybe also interesting, I will bring that up at the ISO meeting in 2 weeks, and because that would be maybe quite useful, yeah.
Sure. Thank you. Yeah, absolutely. I mean, it's a new tool for us that we've developed, but we are starting to have it in all of our demo systems as well. So I know we have demo systems in Europe, and my colleague there, Bulin Picker, has also talked about this in the past as well. So yeah, I think that would be something very feasible, because it's a new and different tool. And the more response we can get from people like you, everybody in this room, how functional it is it useful? Is it something that we need to change and do differently, right? So yeah, I think that'd be a wonderful idea. Thank you.
Just one other thing, this is the beauty of the corporate partners group, is that during our evident demo, we introduced the regional evident manager to Peter Brunt from AVR Optics, put them in touch, because they are realizing how useful it would be to have the Argo-like tools with a pattern to check the resolution of the system. So this is all ongoing.
Yeah, one more question.
Thank you. Nikki Bailey with BINA. I have a very quick question for Jens. And first of all, thank you very much for staying on so late. Lovely presentation. And the resources that you showed are phenomenal. Are they available in other languages? So it's an effort within BINA to try and make training materials available in other languages, and particularly for us, French and Spanish, but also with the African community, Portuguese, and the Latin American community. So is there any effort to make these training materials available in other languages? Because I don't think we have the resources to do a lot of the translations of those, unfortunately.
That's a very good question. The quick answer is for most kids, not the optical microscopy course, but for all other kids, German is available. And we've been thinking about this for quite a while. The problem is the overhead that this generates is substantial, because, once you do an update, you will have to translate into all of those different languages. I've talked to different educators who have done a translation just by putting it into, for example, DeepL translation software. And this has become so ridiculously good that it did not take them a lot of time to read over the entire thing and just throw out the little mistakes that were left. So we are more than happy to provide the Word files of our manuals, so you can easily throw that into translation software. At this point, we're not actively working on other languages.
Right, thank you very much. We're gonna have a quick tech bite. I'll let Vanessa take over.
Yeah, well, John at the back of the room is helping us set up for the tech bite. I did just want to mention, Jens, you're in luck that there actually are a number of Thor Labs kits here. So those of you who are staying for the lab tours on Friday, you can check them out at ECB. We'll share way more details on that tomorrow, but show and tell time later. All right, thank you,
Thanks.
Jens, again, and thank you to all of our panelists.
Thank you. Bye. Bye.